What's up everyone, welcome back. Patrick here, and in this next video we have to simplify this expression here. So we got x to the negative 1 times x minus 2 minus x times x plus 2 to the power of negative 1 all over x to the negative 1 times x plus 2 plus x times 2 minus x to the power of negative 1. Now when I get something like this, first thing I like to do is actually change any negative exponents to positive exponents if possible. So notice that here in the numerator, this x to the negative 1 times x minus 2, we could bring the x to the negative 1 down, so we could rewrite this as x minus 2 over x, right? Because x to the negative 1 is like 1 over x to the 1 to the positive 1, which is just 1 over x. Just in general, if you have x to the negative a, that's equal to 1 over x to the power of positive a. So that's what we are using here. So this and this are the exact same thing. And then same thing over here. This x doesn't have an exponent, so we would leave it, but this x plus 2 to the negative 1 we could bring down, and it would become x plus 2 to the positive 1. And because it's just to the positive 1, we don't even need to put an exponent there. We don't even need the bracket actually either, like that. Right? And then this is going to be all over here. It would be x plus 2 over x plus x over 2 minus x to the power negative 1. Bring it down. It would just become 2 minus x to the power positive 1, which is just 2 minus x. So it's still fairly complex and not looking the best, but in my opinion, this looks better to work with than this. I feel like looking at this is more complex than looking at this, because here, even though there's a lot going on, we can tell what we're going to have to do is we're going to have to take the numerator and make it into one fraction, one rational expression, and we're going to have to take the denominator, make it into one rational expression. And then from there we could simplify. We're going to have one rational expression divided by another rational expression. Now from here we can get some restrictions, like notice x can't be 0, x can't be negative 2, x can't be 2. But I would actually wait until we have it in that format where we have a rational expression divided by another one to get the restrictions then, because there's going to be a couple of restrictions that we can't see right now that are going to come in later as well. So from here, to put these as one rational expression, both of them, notice that they're fractions. So to combine these into one fraction, we need a common denominator. So we would multiply this x by x plus 2, which means the top we have to multiply by x plus 2. And then this x plus 2 we would multiply by x, which means this top here we have to multiply by x. Right? So just working with this numerator on the side here, we would end up with x plus 2 times x minus 2 minus x times x, which is just x squared, and that's going to be all over x times x plus 2, like that. And so let's expand the numerator, so that would be x squared minus 4 over here. That's a difference of squares, so then we'd have the minus x squared all over x times x plus 2. Notice the x squareds cancel out. We're left with a negative 4 over x times x plus 2. So this numerator simplifies into that right there. So we would write negative 4 over x times x plus 2. And then all over this denominator, we're going to do the same thing, simplify it into one fraction. So we would multiply this by 2 minus x, multiply the top by 2 minus x, and then we'll multiply this by x, multiply the top by x. So we would end up with x plus 2 times 2 minus x plus x squared all over one denominator, x times 2 minus x, like that. And then foiling this out, it's kind of weird that we have an x here and then a 2 here. So what I'm actually going to do is I'm going to take out a negative from this bracket, put it in front. You don't necessarily have to, just to change this to be x minus 2. Right? If we take 2 minus x, take out a negative, we would end up with negative 2 plus x. All the signs would change, which would be x minus 2. You don't necessarily have to do that. You could just FOIL from here. But I personally like to do that because then from here you could just tell that that's a difference of squares. And then we have a plus x squared. And so what would happen, the denominator stays the same. This would end up being negative bracket x squared minus 4. And then we'd end up with negative x squared plus 4. Plus x squared all over x times 2 minus x. And then notice the x squares would cancel out. So we'd end up with 4 over x bracket 2 minus x like that. So if you did want to FOIL off from here and then simplify with the x squared, just make sure, whichever way you do it, that you're getting a 4 in the numerator. That's what it's going to simplify to. So this would end up being 4 over x times 2 minus x. And so now notice we have a rational expression, one fraction like we wanted, divided by another fraction. Look how much better this looks than all of this over here. So we could rewrite this as negative 4 over x times x plus 2 divided by 4 over x times 2 minus x. And then from here, let's get the restrictions. So notice that x can't be 0 from these two x's. X can't be negative 2 from that bracket. And then x can't equal positive 2. It's harder to see, but basically 2 minus x can't be 0, which means 2 can't equal x. So those are the 3 restrictions. Right? And then because we're dividing, we always get a restriction from the numerator as well, but because there's only a 4 in the numerator, then there's no restriction to get here. But if there was like another bracket, let's say like an x minus 5, then x can't be 5 would still be a restriction because that would make this 0, which would make the whole thing 0, and you can't be dividing by 0. Right? That's why I suggested to first get it in this format before getting the restrictions, because a lot of times, not in this specific case, but a lot of times you'll get additional restrictions here from this numerator, which wouldn't be apparent in this format that we had before. Right? So we have all the restrictions, and then from here it's just simplifying. So how do we simplify? Well, we're dividing by a rational expression, so that means we flip it. Right? And then multiply these out. So notice that the x's would cancel out, the 4's would cancel out, and so we'd be left with negative bracket 2 minus x over x plus 2. And to make it look nicer, bring the negative in, and we would end up with x minus 2 over x plus 2, like that. So if you get something like this, you want to take an expression like this, change it to positive exponents. A lot of times you'll just get this as a question, this format here, without needing this step, but I just wanted to add this step in case you run into it as well. When you get something like this, multiple rational expressions in the numerator and denominator, combine them to be one rational expression in both, and then it just becomes a matter of dividing two rational expressions. Get the restrictions, simplify, and you get your final answer.